grill. I have to apologize. There is some LLM in our talk, so but it's just a small part of our pipeline. So for those who don't know me yet, I'm Danny. I'm a data scientist at Lampenwelt, and today we will show you how to do an end-to-end framework for assortment and product matching to streamline our product purchasing process. So let's just shortly go over what we'll do today. So first, we have a short introduction, and then we have the user story. So the teams come and want something from us, and we deliver something, right? So, and we want to do it in such a way that we don't have to do it every week or every 2 weeks when they have a new question. So we provide them with a framework to do this. And then we will go into how we actually do it and how we start from the data ingestion to the data activation to serving the front end for our customers, so to speak. So short introduction from us. We are Lampenwelt. We are an e-commerce company based in Germany, and we have web shops all over Europe. So if you're ever traveling somewhere in Europe, you will always find a shop to purchase some lamps and lighting from us. So we focus on this. So we are a pure player for lamps and lighting, and we have over 50,000, even over 60,000 SKUs for you to purchase this year. And this also comes with some problems, as you will see later on. So this is our team. We are a relatively small team. There's Mario, our product owner, which is also here today. There are our 2 data engineers, Vasef and Tim, which are more on the data side of things, into the business logic, the data transformations. And then there's me, Danny, the data scientist, doing the ML stuff and actually activating the data for our business teams. This is our architecture for those of you who were here last year. We have finished deploying and are now in the phase of actually using our architecture. Of course, first the ingestion, we use Fivetran where possible, but for some connectors it doesn't work, so we use custom Python scripts for incrementally loading our data. Then in Databricks on AWS, we have our core business logic. We use dbt for all of our transformations. And we then serve the business logic to Athena QuickSight for dashboarding, for our management, and also to other upstream services such as Salesforce, Google Ads, marketing channels to steer campaigns, and so on. So what happened? Category management basically came to us and said, we have some products we want to purchase, but we don't know if we have it in our assortment. We have 60,000 SKUs to check, so can you help us with that? And then we think for us, we don't really want to do that as well. We don't want to check 60,000 SKUs, so what we do instead, let's build something. Let's build a matching tool, which is self-service, which you can use on your own. You just have to upload images, and you get, if available, matches from our own assortment. And we already did something like this 2 years ago. It was a little bit more of a POC back then. But we wanted to do it better this time. So we started doing this in August, actually. So it was a 2 to 3 week project. So it was quite fast in our infrastructure. So this is how the category management wanted it to have. So you have an input, and then you have some kind of black box, and you get products out. And as you can see here, the top right is the same product. So question is, do we actually want to purchase this lamp for our store to add it to our assortment? Or, okay, we have it already. Do we need to purchase more of them? Yeah, that's a question they need to answer then. For us, it's a little bit more complex than that. We actually divide this into 3 pillars, so to speak. We have the data, we have modeling, and the deployment. Most important is obviously the data. Without data, we can't do the modeling. But we also need to decide on which data we actually use and need for the model. So we decided we will use embeddings. We have heard about embeddings today already. They are a big part of LLMs, but they can be also used for different things such as image matching, right? So yeah, we did this 2 years ago. It looked kind of like this. There were 2 key issues that we had. One, we didn't have a label for clipping images, so white background, just the product. And we found that it works best if we just have the product in focus without unnecessary noise. So this was one issue, and the second issue was the overzealous data scientist who wanted to build a model on their own, tried to train it, and trying to beat Google and other proprietary systems. So it worked quite okay for some images, but in the end, using a proprietary model that has been established for many years is working much better as a baseline, as we found. So, to address the first issue, the clipping images, this was actually done by our media team, our asset team. They said, okay, we also need labels for our images. So, what can you do? One, you can ask someone to label all your millions of images by hand, which might take a few months. And I think you're going crazy if you do that, so don't do that. Instead, they actually used an LLM as an image classifier, which worked quite well, I have to say. I was very surprised that this worked, and they did this all on their own. We did a little bit of support for them, but it was them actually doing this to label images. And how did they do it? They started with some AI background removal to remove the background, so we have at least one clipping image for all products. And then they used a prompt and asked ChatGPT to label images based on what ChatGPT sees on the image. So we had like this mood, we had clipping, dimensions, and detail, and some more labels. But what we were most interested in is, of course, the clipping image. So this is what we actually wanted, and they gave it to us. So problem now, the data part. Good news, we had the labels. Bad news, they put it in some digital assets management where we needed to do some API calls to get the data. This is our DOM, and this is just the basic workflow of how we do it for non-supported 5-chain connectors. So it's an incremental load. We check always for updates. We do this every week for these images because they don't change too much. We then dump the raw data messages. They are JSON messages from the API into a table, and then normalize them based on our architecture. So we use Databricks SQL, so we need flat tables with IDs, with keys, so we can join and use them. And we also use Terraform to just put everything into place so that we can't lose it, and that it's always tracked in version control. Yeah, so because this is a little bit dry, I brought something for you. I found a quite interesting lamp. So this, so this is something I found using our tool, which is an alpaca lamp that you can actually buy from us. And the right side is basically what the API response looks like for one of the products. It's quite nested. There's a lot of attributes we don't need. And we need to start to dig a little bit. This took quite some time. I say, a day or two to get this sorted. And we just split all of this, the JSON message, into separate tables. And there we have, we have a link there. Okay, we can use that. There's the category, there's the clipping. And we also need an SKU, of course, to match it to our foreign key. This is a foreign key to our dimensional model, where we then can use the attributes for the product to display in the app. So, with that being said, we load this data every day, and this is this is quite a low resolution. Sorry about that. Yeah, so this is our first layer is basically the data source to the left, the clip lister DOM, and then Databricks acts as our data backend where we have the product images and the image metadata. Yeah. So now we have the data, we have the images, what do we do with it? So we said we wanted to use embeddings, and this is what we do. Just a short reminder on what embeddings do. So we have an input image, we put it into a model, in this case a neural network of some kind. We use Google GCP for that. It's called a multimodal embedding model, and what we get out is for each product image one n-dimensional vector which we can use to compare images. So we can use cosine similarity dot products to find out how close these images are in the embedding space, which is much easier than comparing images pixel by pixel. I can tell you that. So then, this is a slide from Google Cloud Next, which kind of explains how this multimodal embedding works. It's similar to the unimodal embedding, but in this case, we cannot only put images into it, but also text. And the idea is that if we have an image and the text that are semantically close together, so in this case, the text describes the top picture, and then they will also be close in the embedding space. So this means we can put in text and compare this to our image data by image embeddings and find actually similar images just based on text. So we can also use this for videos, for audio, for all kinds of unordered semantic information. So then we extend our model by this Vertex AI layer. So we still use Databricks as a backend, and we extend it by using an embedding model, store the embeddings in the embedding database, in Databricks again, and then manage the index, which is also in Vertex AI GCP for our use case. And basically, we do this also every week, and we use this database just to sync with the search index in case images get taken down, products are getting taken offline, and so on. And finally, the deployment. Of course, we need to somehow serve this to our customers. For that, we use Kubernetes, also on GCP, Google Kubernetes Engine, on Streamlit. We're not front-end developers, so it's easy for us to use tools like Streamlit to rapidly deploy a front-end for our customers to use. We also have two environments, production and testing, so that we can just patch and update and test new features, and the teams won't notice anything. So this is like a continuous deployment setup where we can just put images. It's basically a mirror of the production environment, just with new features that we add during a merge request or pull request. Yeah, and this is then the full stack. We have our data source backend, we have the data warehouse backend in Databricks, and then we have a front end with it, which is hosted in GCP with an ML layer and a deployment layer. And then finally, the full matching service. How does it look like? This is currently the front end. It looks a little bit sparse, but it does its job. So you can just drag and drop a file, select how many images you want, and select a threshold between 0 and 1. 1 means exact match, and 0 means no match at all. Then let's upload our alpaca, and this is the result. So we get actually the same, so we get an exact match for the image, but also similar images just rotated to some degree, and it's all the same product in this case, because we only have one alpaca lamp. So maybe in the future we will have more. But you can also do the same with text search. So in this case, I'm searching for a black desk lamp, and as you can see, you get multiple different desk lamps. So yeah. So finally, yeah, this is our framework. We split these tasks into data model and deployment to just have a clear definition of what to do at what point. Yeah, we automate the whole process from data ingestion to activation to serving the model, so that we can now sit here and talk and enjoy our time, and the software and the front end is just running and updating on its own, and we don't have to do anything anymore. Yeah, and with that, thank you.
So before asking for questions, think about it. I would like a link to the lamp. I think my daughter would love it. My wife probably will not. Do we have any questions for Danny?
Thank you, very interesting talk. Did you do any systematic evaluation to measure how well this search is doing? And the second question is, do you capture any information from your users, like whether they click on the link?
So the evaluation is quite subjective because it's like an image evaluation tool. So the evaluators are our category management who tell us, okay, this doesn't work. And we collect these examples, but in case of the Google algorithm or the Google model, this is one of the downsides, that we can't fine-tune the model. So if we wanted to improve upon this approach, we would need a model from Hugging Face, for example, which you can fine-tune with our own assortment. A second question, we did this in the first draft, we did in the POC, where we could rate the results from 1 to 5. We haven't implemented that yet, but it's something we consider doing in the future. This is really just the bare bones feature, the bare bones frontend that we implemented in August. Yeah.
Any other questions? I have one. I mean, you said that this was a fast iteration, right? In general, which is a good approach. Can you share something that it didn't work? Something that you expected that it would work, and then so how you dealt with failures? Any anecdotes there?
From this second iteration, I think the only thing that really didn't work initially was the data ingestion. The API was a little bit obscure, but it worked in the end. From the first iteration, I think, as I mentioned, the overzealous data scientist, don't try to build your own model if there's resources available for you to use. You can always, if you have time, then improve upon existing resources. We don't need to reinvent the wheel. So this was I would say, failure. Yeah.
Thank you, Danny. Oh, we have a question.
Yeah, hi, thanks for the talk. So I was wondering, have you thought about like opening up this to the customers in an app or something like that, where they can make like a photo of a lamp they see on the street and they want to purchase, and then you can see like the results from you?
Yeah, sure, that's definitely something to consider. I would say it's not in our decision-making process to open this up. If front-end or shop team wants to employ this feature, yes, we absolutely would deploy it with some additional filtering, of course, to prevent rogue uploads.
Yeah, so Amazon has tried this with limited success. So I would think, like, for a company of their size, the risk is just too big, and probably if Amazon can't make it work, it's difficult to make it work. Okay, so let's thank Danny one more time.
Yeah, thank you.